Hey everyone, this is Anshul Sadaria, software engineer at Google. In this video, we are going to do a live C++ project on low-level system design, covering the concepts of object-oriented programming. So, before we do that, don't forget to check out Scalar's free masterclasses taken by industry-leading experts only on Scalar's event page. Link is in the description below. Now, let's start designing. So, what are we actually going to design in this video? We are going to cover a vehicle parking system. So for example, like whenever I used to go to movie theaters, malls and all of those places where parking used to be a headache, right? The security person would tell me turn left, turn right, and then there was no end where to actually park the car. So this used to get very frustrating and I was like, why can't they develop an algorithm which decides what are the empty spaces and tells the user that, okay, go and park in the grid GD or G1 or G2 or whatever the cell number is, right? So that is the main motivation behind designing this system. Obviously, we are not going to take it in depth and extend it to a full-fledged product. We are going to decide what classes we are going to use, what will be the attributes and the functions present in those classes, and then how they will interact with each other to create a bare bone minimum viable product, which someone can use for a parking system and maybe extend it to a full-fledged product in the future. So we are going to use C++ as the programming language for this. And before that, I think this should be a valid confusion among some of the viewers that, okay, what is the difference between low level design and high level design? Right? Low level design versus high level design. So this a decent understanding of what are the distinguishing features is important. Okay, we have covered a lot of high-level system design videos about, Uber and then hotel reservation system, Tinder, Twitter, and so on. So a distinguishing part of those system design topics is that we look at the system from a very high level, as in it's an airplane view wherein we check what services are there, what systems are there, what are the subsystems present in them, what subsystems interact with each other, and so on. But low level design is more like a bird's view, wherein we get a closer view about how the systems are interacting with each other, what is happening inside a subsystem and so on. If I wanted to give you a real life analogy, let's take up a car. Okay. So what are some of the systems which are present inside the car? I mean, I'm no automobile expert, but some decent understanding, hopefully I'm right. You can correct me in the comment section if I'm not. Okay. So there will be a fuel tank, obviously. Okay, then there will be some power windows. There will be an internal combustion engine. And some more systems interacting with each other. So now in a high level design, what would I be knowing? I would be knowing that there will be some fuel inside the fuel tank and that fuel will be used to power the engine. It will be passed to the engine and then it will go through combustion process and then it will give energy to the car to move ahead. Okay, but what exactly is happening inside the combustion engine? How is the fuel getting combusted? What is the velocity of the fuel? What is the flow of the fuel? How many liters per hour or whatever the dimension is? Like the internal happenings are not so visible in a high level design. If I take example of a power window, I just know that this will help me open and shut down and open the windows, but I don't know what mechanism is underlying that particular interface. So all those deeper discussions will happen in a low level system design, wherein we will define how these systems are actually interacting with each other. So in low level design, in-depth discussions of house is happening. Okay, not the home. I'm talking about the how part, like what is actually happening, how it is happening inside that particular system. In-depth discussion of how things are working under the hood. Now in high level design also, if you remember from the system design video of a hotel reservation system, we talked up to some depth about how the booking is happening, but we didn't cover what all logic is going to be followed, how we are going to implement the hotel service and all those different services that we talked about. So you don't expect to have a complete understanding about how the services are going to be functioning when you're actually going to implement it. So when I talk about from a granularity level, it's going to be high level system design followed by low level system design followed by translating that low level system design into a code. Okay, so that is the granularity level. And things obviously change. I mean, what you might be imagining in a high level system design could be starkly different to a low level system design, because then you will have more understanding about the technical feasibility of those things. So now I think this difference is sufficient enough to convince you that why low level design is important and how different it is from a high level design. So I already talked about the problem statement. So basically what we want is we want to design a parking system which helps the users know from the beginning that where a vehicle should be parked. They should be facilitated with payment system as well, like what is the amount of parking fee they should be paying, and upon the payment of parking fee they can vacate the particular parking spot and new car or any vehicle can be parked in that place. So let me just officially write it over here. So design a vehicle parking system which looks for vacant spots in the parking and facilitates payment of parking fee as well. Payment of parking fee. Now this is our Uber level problem statement, and now we are going to translate this statement and understand what different customer user journeys are there similar to what we used to do in high level system designs as well. So from those user journeys, we will understand what the functional and non-functional requirements are there. From the functional requirements, we will decide what the class diagram should be. If you remember in the high level system designs, we talked about an ER diagram, which meant what is the schema of the database, what database we are going to choose and so on. It used to be entity relationship diagram. In this case, here also we are defining some entities, but these entities are lower level entities, like what the class schema should be, what all attributes should be there, what all member functions should be there and so on, and how they are going to interact with each other if there are any interactions between them. Okay, so customer user journey, first of all, a vehicle will enter the parking system. Vehicle enters parking. Then next, a vacant space is found for the parking. Then the vehicle goes to that place. I mean, navigation and all of those graphical things we are not assuming over here. We just want to create some interfaces to simulate the parking mechanism. Okay, so the third step should be vehicle parks in that spot. Parks in that spot. Now you might be wondering, what if the entire parking is full? Then we obviously throw an error and tell the vehicle that, hey, no parking is available. Please try after some time, or please wait till a vehicle vacates a spot or something like that. There can be any sort of an error handling mechanism which you can implement. Then after the vehicle parks in that spot, there will be, like, if you remember in real parking systems, so there is a token given to you which has the start parking time, like the moment in which you entered the parking, and then when you exit the parking, the time is calculated, like how much time were you in the parking, was your car or vehicle parked in the parking, and based on that there is some parking fee which is calculated, and when you pay that fee, after that you are allowed to exit the parking. So then fourth part should be calculation of parking time. And then we can write it in a single user journey, calculation of parking time and parking fee. Then lastly, vehicle leaves the parking. Okay, so this should be very simple enough to convert into functional requirements, first of all. So we need to properly decide what should be the scope of our project, because we are trying to build a minimum viable product. So you would know that in real parkings there are multiple floors like upper basement, lower basement, and then basement 2 and so on. But right now let's begin with a 2D grid of a parking and then we can scale it up. So let's start. First of all, there is a 2D parking and we can capture it using a grid. Capture it using a grid. Now the next functional requirement would be, if I look at my customer user journey, find vacant space, find vacant spot for parking. Occupy the vacant spot from functional requirement 2. And then we will start the calculation of our parking time. Start clock for parking start time. Then we want, like, based on whenever we are leaving the parking, we want, based on whatever the parking start time was, we want to calculate the number of hours or whatever, like minutes or seconds or whatever we want to. In this case, we will prefer hours. So calculate duration of parking and then calculate parking cost from 5 and then vacate the space for other vehicle. Now these functional requirements will be converted into public interfaces which our classes are going to provide. We will decide what classes we want for this particular system, and then based on these requirements we need to provide suitable interfaces for the users. So now you might be wondering, what are the non-functional requirements over here? Like if we talk about high-level system design, it should be low latency, high concurrency, high availability, and so on. But since this is a low-level system design, we are going to talk in terms of classes. So first of all, we want our classes to be modular so that they are easy to understand and implement. Then we want them to be extensible, because let's say right now, if I choose some classes and I want to add some functionalities in the future, then it should be simple enough. The classes should be extensible enough. Extensible. The code should be designed, or the classes should be designed in such a way that they are easy for debugging and testing purposes. So easy for testing and debugging purposes. And I think one requirement which can be, for example, let's say if 2 cars or 2 vehicles are coming at the same time, okay, and there is only one spot left, or there are multiple spots as well. We don't want both the vehicles to be parked in the same spot. So we need to be able to handle concurrent request, and in case of C++, we can use multi-threading, but probably this can be this can be a future scope, and it need not be part of our minimum viable product. Okay. So this can be a future goal. Handle concurrency, and this we can do using multi-threading. Like if you are interested in understanding how we can use multi-threading to handle the concurrency issue in this case, let me know in the comments so that we can create a project for the same about multi-threading in C++ as well. So that will be an amazing addition to this particular project as well. So this can be a future goal, and I think this is it. I mean, you can just think about some other non-functional requirements which you want. So modular, extensible, and obviously the classes or the functions which are exposed should be designed in such a way that their time complexity and space complexity are optimized. So that should be one of our primary goals as well. Optimize time and space complexity. And this indirectly translates to latency and better resource utilization. So I think these are good enough non-functional requirements, and we have already decided what functional requirements we want to get started with. So we are good to go. But to those who, like, just to give a quick recap of our object-oriented programming paradigm. So there are 6 dimensions to it. 2 of them are classes and objects, which are the main functional units of object-oriented programming. Then comes the concept of encapsulation, which means we want to protect our data. We want to decide how the control of updating and accessing of the data should be using the access modifiers, whether we want to provide getters and setters for a particular attribute or not. We want to decide what should be private, what should be public, and what should be protected in case we want it to be inherited and used in the child class. Then comes abstraction. We want to expose a user-friendly interface so that the user doesn't need to worry about what the implementation is. They just need to know the definitions of whatever public interfaces we are exposing, and they should be good to go with it. Then polymorphism. Now polymorphism is sort of a gift. It's not a fundamental thing that we should be implementing. Okay, it's not a must. It depends on our use case, how we want to do, and we will be covering that part in this particular module. We will see in this particular project, we will see like how the classes can have overloaded functions or overriding functions and so on. I will keep that as a surprise, and like you can just make a guess if you want to right now that what all parts can be overloaded in case of our system, what classes are there, what functions we can expose, and so on. And lastly, inheritance. Now, inheritance is a crucial part of object-oriented programming paradigm because we want to reduce the redundancy in our code. We want to modularize our code in such a way that the parent class covers as much common functionality as possible, and then the child classes which are inheriting from the parent classes have the necessary required interfaces or have the necessary required attributes which they want to be covered. For example, like in vehicle parking system, we can probably have child classes like cars, bike, or trucks. I am not sure if trucks should be parked in a parking lot like movie theaters and so on, but cycles probably. So we can have such child classes which can inherit from a common vehicle class, and then we can use inheritance for that purpose. So these are the 6 dimensions of object-oriented programming in C++, and we are going to be working around all of them. So now let's decide on a class diagram, like what all different classes should be there, what all attributes should be part of our classes. So the first one, which is like the most intuitive one right now, since it's a vehicle parking system, vehicles and parking lot, like both of them are must, obviously. Right? Vehicles is one class and parking is another class. Now, what do we need in a parking class? We need the number of rows, right? Like what is the size of the parking is important for us to decide how many vehicles can occupy the parking and so on. So rows should be there. Then spots per row, probably. Something like that. And what all can we have? Obviously, we need to have a grid in place so that we can store the vehicles which are there in the parking. So we can have a 2D grid. So in this case, we can use probably vectors to simulate that part, but in like just to name it, it should be a grid. So this is an integer, just to label the data types. Both of them are integers, and this can be a vector of a vector of vehicle class. Like we can use pointers to the vehicles so that we can have the luxury of runtime polymorphism whenever we want to. If you didn't understand what I said just right now, do revise to the module 3 of C++ course where I talk about polymorphism and runtime polymorphism in detail. Okay, so I think these attributes are sufficient. Now, what all member functions should be a part of this particular class? We can have create parking, obviously, like that should be sort of a constructor for us. So we can use create parking, and it should actually take in the number of rows and number of spots per row, and then we can create the grid of that particular size so that we can store vehicles in it. Then we should have find vacant spot, because that was one of our functional requirements. So based on the values inside grid, whichever is a null pointer, that should, like, whatever first null pointer we encounter, we can return that value. So find vacant spot. Okay, this can be one of our member functions. Then park can be one of our functions. Leave can be one of our functions. Inside leave, what we can do is probably we can calculate the time taken by that vehicle and calculate the parking fee as well. So these functions are good enough probably. Now moving on to the vehicles part, the first attribute, like one attribute which is important to have a decent mapping between the vehicles and the parking, is the cell in the grid where it is stored. So row number where it is parked and spot number probably. So this tells us the exact place where the vehicle is parked, and then we can also have a parking start time, so that we can calculate at the end whenever the leave function parking is invoked, we can calculate based on the start time and based on whatever the current time is, how much time did it actually take. Okay, so we can have a parking start time. So both of these in the case are integers. For parking start time, we can probably use the Chronos library. So I also don't remember the exact syntax, so I will be googling while designing, while actually coding it. But just a hint is sufficient over here, that we will be using Chronos library. Okay, I don't remember the exact data type for that, and that is not expected out of you as well, because this is an unconventional library which we don't frequently use. So now, what all different member functions should be part of this particular class? So first of all, maybe this can be inherited by different classes, like car in this case. Let's start with car, then we can add other vehicles as well in the future. So that's how the extensibility of our class diagram will come into play. But what all functions should be there in the base class itself? Let's say vehicles is a base class, then row number, spot number, and parking start time. I think these are good enough to be kept in the base class. We don't need to redundantly mention them again in the child class as well. The child class can directly use it from the base class vehicle. So now some of the functions which we can use is occupy spot. Whatever, like when we do find vacant spot, we will get a pair of row number and whatever column number it is, and we should probably occupy that space. So occupy spot, wherein we will get a row number and a column number, and we will take that particular place. Occupy spot, vacate spot whenever we leave the parking lot. Then this should also be common. It doesn't matter if it's a car or a bike. Both of these can be kept in the base class itself. Now after this, what do you think we should keep in the base class? Probably calculate parking hours, because parking hours is going to be the same, because since we are storing parking start time in the base class, we can calculate our parking hours in the base class itself. Calculate time. Okay, I'm just writing it because I don't have a lot of space here, but calculate time in this case. And for this, we will use the Chronos library once again, based on whatever the time is there at the time of leaving the parking, and whatever the parking start time was, we'll calculate the difference, typecast it into hours, because I want to go ahead with hours, and then we can calculate the time. So now, two of the functions which come to my mind, which we can classify as virtual functions, and we would use pure virtual functions in this case. Don't worry, I will explain what exactly I mean by pure virtual functions. So what are those classes? Calculate fee, So in this case, for bikes, there will be some different type of fee. For cars, there will be some different type of fee. So we will mark this as virtual. And we want this to be a pure virtual function. So just to notify you that equal to 0 is used to make a virtual function, pure virtual function. And this will in place make the vehicle class an abstract class. It's not required to understand what exactly pure virtual functions and abstract classes are, but abstract classes cannot be used to create objects, first of all. And if there is an abstract class, you need the child class to actually implement those pure virtual functions. Otherwise, the child class which inherits from that abstract class also becomes an abstract class. So if you want to create an object for that child class, you need to provide implementations for these pure virtual functions. So calculate fee can be used, and we can also create another virtual function which will be for get type. Okay, what type of vehicle it actually is. And now you might be wondering why do we care what type of vehicle it is? Like, we are not having any bias for like whether some spots are reserved for cars or some spots are reserved for bikes and so on. But this is for future extensibility purpose in case when we add bikes as well, and in case we have some reserved spots in the parking like we usually have. In a real parking, there is a designated space for two-wheelers. There is a designated space for four-wheelers as well. So right now we might not need it, but it's good to have like get type, what type of vehicle it actually is. And this actually we can provide, like instead of making them pure virtual functions over here, we can provide them in child classes as well. But keeping them as pure virtual functions in the base class forces the child classes to implement them. So maybe whoever the author of bike classes, they might miss out on it. So here we have provided them as pure virtual functions. So they will be forced to implement it so that we don't miss out on important public interfaces. So this is also defined as a pure virtual function. And I think at this moment, these are good enough to go. Like, we can inherit from the vehicle class. We can inherit a car class and a bike class in future. We will start with a car class. And if we get time, we can also implement the bike class as well. It should not be a big deal. In the car class, we need to provide implementations of calculate fee and get type and any other attribute that we want to add, but I think we might not require any other attribute. So yeah, I think there is no requirement for adding extra things. We just need to implement the pure virtual functions. So now this class diagram is good to go in my understanding. Probably we can have like, in this particular system design code, I'm not going to actually make an implementation of a payment system wherein some payment or some transaction actually happens, because we don't have any payment gateway. We don't have any facility to keep accounts and everything. So as an extension to this, you can probably cut out the payment part from the vehicles and create a new class, which is vehicle payment, and probably inherit, like create child classes which inherit from the vehicle payment class, and the child classes can be car payment, bike payment, and so on, in which we will have the special formula of calculating the parking cost based on the parking time. So now let's start coding. So let's create a file parking.cc. Okay, parking system.cc probably. So we'll start with our header inclusions bit/std c++.h. Now this is a header library which I did not talk about in the C++ modules. So this covers all the functionalities which are provided by the standard template library, so that I don't need to explicitly include the Chronos library or the library for vectors and so on. This does the work for me. I can use the namespace std in this, and there will be an int main function. Now let's first start with talking about our classes. So the first class, let us make it vehicles, because if you notice over here, our parking class depends on the vehicle class. Like, we are using vehicle class in the grid attribute. So we will need to define the vehicle class first, and after that we can provide the definition for parking class. So Now this attributes, I want them to be private because I don't want anyone to randomly change the row number and the spot number. So I will have row number and spot number. Now I don't remember the implementation, like whatever the data type is for parking start time. I will just comment it right now and I will Google it at the end whenever we want to wire everything up. So parking start time is an attribute which is remaining. We will add it soon. Now some of the public interfaces that we want to provide. We will start with the constructor first. So if you notice, we have provided row number and spot number as integers, so that default values will be 0 whenever you initiate that particular class. So we actually don't want the row number and spot number to be 0 because then it would be a valid parking spot. So whenever a vehicle is created, the row number and spot number should be some non-valid value because they are not parked yet. Okay, they have just entered the parking system, but we have not yet assigned them to a proper parking spot. So let them be -1. Right, to get started with. Now if I look at my class diagram, we have occupy spot, vacate spot. So I think this should be simple enough unless something comes up while implementing the parking class. So the return type for occupy spot should be void because we are just updating the values of row number and spot number. So in this case, we will get int R for row and int C for the spot number, and we will update both the values. Now if I'm making any mistake while coding, do write in the comments. I hopefully would be able to resolve it while this live coding session is going on. And also a fun activity for you. I will keep on compiling at regular intervals. Your task would be to calculate the number of times the compilation fails before the actual code runs. Okay, and let me also start the timer in my mobile so that I keep a track of how much time does it actually take me to code this thing. Okay, so I'm just starting my stopwatch. I just begun it right now. I will add 2 to 3 minutes because I have already coded something. Okay, so occupy spot is done. Now when we want to vacate spot, probably at this point it is safe to consider that like the parking class, whatever the interfaces we are providing in parking class, they will manage whatever duration it took for the vehicle, like whatever duration the vehicle was parked for and so on. So in this case, we again have the void return type, and for vacate spot, we don't require any attribute, like we don't require any parameters. We can just make the row number and spot number to be invalid once again. All right, next we have calculate time. So that I will just comment it over here because I'm not aware about what the exact functionality is provided by the Chronos library. So I'll just comment it. I don't know what the data type is, but the definition would be calculate parking duration in hours. Okay, in hours. Now, does this require any input parameters? I don't think so because we already have an input parameter, like we already have an attribute which keeps a track of what our start time was. So we can just mention in comments over here, use parking start time and current time. Okay, this is just a hint for me whenever I am actually implementing this part. Now, if you notice, calculate fee and get type, both of them are virtual. So we need to still like mark them as virtual, pure virtual functions. So calculate parking fee. Now this is the nomenclature for marking a function as pure virtual function. And this will be get type. I have missed out on the return data types. So this will be integer. Parking fee can be double actually. Or let's keep it integer for a whole number. Let's not add a lot of confusion here. And get type can be string, like it can be a car string, it can be a bike string and so on. Now, I think this is good enough for the vehicle class. I will just take a look in some time after I inherit the vehicle class to a car class. So let's define the car class. It will have a public inheritance from the vehicle class. And also one important thing to not forget is the semicolon after the class definition, which I usually forget. I hope you won't be making the same mistakes that I am making. Now, I don't think we require any private attributes in the car class because we are not storing things like what are the number of wheels and so on. But in case if we require in future, probably let's do one thing. Let's have one private attribute which says int. I think this is also constant. So private attribute is not required. What I was thinking was maybe we can define a private attribute which is like a parking multiplier. For example, we can have 5 times the number of hours for cars parking fee and 2 times the number of hours for bike parking fee and so on. But since that is a constant, we don't want to keep on updating it. Let's keep that as a constant. Now let's first implement the virtual function. So get type, and this will just return car in this case. Now calculate fee is something which we will do based on like whatever the duration is. Calculate parking fee. Okay. Now how we can do this? We can just call the function calculate parking duration in hours. Okay. And this actually, the data type here should be integer. Like we will convert it inside the code itself, but it should be integer. And let's also define it. Let's just keep it vacant. Let's just, yeah, this is good to go because this will provide us an interface even though it's an empty one. So right now I will just replace it with return 1 in this case. Okay, we will replace it soon. And in this case, we can return 5 times calculate parking duration in hours. Okay. So this feels a good place to like complete our definition for the child class car, which is inheriting from the vehicle class. Now we have inherited both the dependent classes. Now we want to define our parking class, which will use the vehicle class. Okay. Now one important observation is the parking doesn't know what type of vehicle it is at the moment. In case we want to extend it in the future to like have some designated spots for cars and like other types of vehicles, then we can use the get type functionality from the vehicle. And using that functionality, we can let the parking decide whether this parking spot is a valid parking spot for a car or not. Right now it's not required. Right now all the vehicles are neutral for the parking lot. So we don't require it. Class parking. Now what all are the attributes? Some of the private attributes here are int rows, like how many number of rows are there. Integer for spots per row. And then we will have a grid, which is a vector of vehicle pointers. Okay. Why we are storing vehicle pointers and not vehicles? Obviously, one thing is to occupy less space because pointers will occupy only 8 bytes, right? And we can directly access the attributes from the pointers. But if you remember in the module, in the C++ module of object-oriented programming, I talked that we can use base class pointers to enable runtime polymorphism. So that will be very evident from the code that we will be writing in future. So this will be the grid. Now let's write the public interfaces. Okay. Now we will first of all, this is a sort of constructor. We can have a proper constructor with the name parking, but I want to make it more user friendly. So we will have create as the input, and in the input we will have int r and int c for the number of rows and columns. And we will first of all assign rows to r and spots per row to c. And then we will also initialize the grid. Okay. Now grid dot resize r Now these are some of the functionalities which I'm using from the standard template library, like resize. So that I can, like, at the runtime, I can decide what should be the size of our 2D vector that we are using. Now we will run a for loop to create space for all the spots per row. Like, we will initialize the grid for each row. Grid of I dot resize C. So at the beginning, all of them will be null pointers. Okay, and as soon as we start parking some vehicles there, they will be storing the address of that particular vehicle pointer. Now let's implement find vacant spot. Now what should be the data type of this? It can be a pair of two integers which will store the row number and the spot number within that row. Now what we can do is we can just iterate over the entire grid and find out wherever it is null pointer. Int I is equal to 0, I less than rows, I plus plus. Now right now my objective is not to write a clean code, so apologies for that. My objective is to make sure that this time is as low as possible. Int j is equal to 0. This is a nested for loop to iterate through both the dimensions of our parking. Now if grid of I comma j equal to null, okay. Now this is what happens when you don't code in a particular language for some time. You need to play around with different permutations and combinations. Now in this case, what we'll do is we will return the tuple, or we will return the pair of I comma j, okay. Now again, I'm not sure about this syntax. Maybe it's round brackets, maybe it's curly braces. So I will wait for the compilation error to happen and then let it guide me what the braces should be. Okay. Now find vacant spot is done. Let's implement park. So this return type also should be void, because like after parking, we don't want that function to return anything. Now what should be the input parameter? It should be like what we are actually parking. So vehicle pointer we will take in as an input. Then we will find the spot where we want to park it. Okay. So find spot is equal to find vacant. And what we want is vehicle to occupy that spot. Spot dot first and spot dot second. Now this is how you access the elements from a pair. We use pair dot first and pair dot second to access the first element and the second element. And is there anything else that we need to do? Yes, we need to update the grid as well. So grid of spot dot first and spot dot second will be equal to v, which is the pointer to the vehicle. Okay. Now leave, when we are leaving, we also need access to the vehicle pointer. And at the leaving time, we already have, like, we know what place the vehicle is located. Like, we just need to vacate that space. But one important observation is that we don't have a public interface as far as I remember. So how do we decide what place the vehicle was located at? So vacate spot just updates the row number and spot number to -1. So our first task should be to identify where the vehicle is located. And here we will create, like, if we try to pass the parking parameter to vacate spot, let's say we try to update the vacate spot functionality in vehicle, then we need to like pass the parking grid as well. But if we pass the parking grid, then it becomes a cyclic dependency, which is not valid. Like parking class will depend on vehicle class and vehicle class will depend on parking class. So other thing which we can do is we can just move around the grid and then we can match the pointers with the vehicle pointer. Let me show you what I actually mean. If grid of I comma j equals to v, it means that it is parked over here. Okay. Now if there is an equality, it means the vehicle was parked in this particular place denoted by row I and spot j. Now the first thing that we want to do is we want to empty the grid. Grid of I, j should again be null. This shows it's empty, and we can also vacate spot. How we can use the pointer to the vehicle. So this should probably vacate the spot. Though this is not optimized, we are again going through an n square loop, like whatever the size of the parking is. But probably due to the cyclic dependency, we are not left with any choices. You can let me know in the comments if there is an optimization to this. I would be happy to hear it. Now we have implemented all the 4 interfaces. Now this is not actually required, but I just wanted to show how a method can be overloaded in the class. So what we can have in park as well, we can just have the places, row number where we want to park the vehicle, and int for spot number. And what we can do is, first of all, if we want to occupy the spot, we will pass these parameters. Occupy spot. And so if you see, since I have overloaded the park function based on whatever the definition we are using during the function call, we will take a call, like the compiler will take a call which function should actually be called. Row num, spot num. Now I don't need this redundant functionality. I can directly call the park function that I have declared below, and for that purpose I need to define it above this function. We will pass the vehicle pointer, we will pass the row number, which is spot.first and spot.second for spot number. And I think this is good. I'm not too sure. Let's compile it first of all and be ready to count my first compilation error. Because it would be a miracle if this compiled in the first time. I never expect it to compile in the first time. Okay. Whenever the code compiles in the first time, my first reaction is there is something wrong, because it compiled on the first go and that usually never happens. So I'm curious, but I will let the time decide. Whenever I implement this parking duration functionality, I will just implement it and we will see what is actually happening whenever we run the functionality from the main function. So now I will just take a pause over here, quickly Google how we can use the Chronos library, and then I will see you with the updated code. Okay, so I have just Googled it and I have added the data types, because obviously I didn't remember all of these. I just knew that Chronos library can be used. So this is the data type for our time, like however we are going to represent our timestamp. And if you notice in the calculate parking hours and duration, what we have done is, first of all, we found out what the current time was. And if you notice, there is an auto keyword that we are using, because like when we use auto keyword, it will try to implicitly copy whatever data type is there on the right hand side. So in this case, chrono system clock. Now I for sure don't know what the exact data type is, so I will let the compiler decide what the data type to that should be. In the next line, what I'm doing is I am just subtracting the current time from the parking start time, and then I'm casting it to hours because my functionality requires it to be in hours. It can be minutes as well. You can just check out what the exact enum is for minutes and you can use it as well. And lastly, what I'm doing is I'm using duration.count to actually get the number of hours it has. So this should be good to go. Let's compile it again. And it is getting compiled, and this is actually scaring me right now. Okay, let's implement the main function and try to park some vehicle actually. Okay, so the first thing that we need to do is we need to create a parking object. So parking p is good enough for name here. Now what do we need? We don't need anything to initialize it. First of all, we can use p.create. p.create, let the parking grid be 3x2. We don't want to create a very big parking for testing it. So now if you remember, I said in the non-functional requirements that your code should be testable. So if you want to actually test it, you can just write in the int main function itself. You can create a new file. You can link this particular CC file in the test file. And then you can, in the int main function, you can invoke different types of functionalities and then assert whether the outputs are as expected or not. Okay, so I'll just create a parking of 3x2. I will create a car C1 and C2. Does it require initializing? It has an explicit initialization without any parameters, so it should be good to go. Now let's say I want to park the first car. So park, we have the park functionality exposed. So what we can do is we can have p.park, and then if you notice the second definition of park, we are using a pointer to vehicle. And if you remember the virtual functions and how we use runtime polymorphism, if not, open a new tab, go to the video where I am discussing about it, and then you will understand how this actually works. We are giving the content, we are giving the reference of the child class to the pointer of the parent class, which is a valid operation. A base class pointer can point to both the references of child class and the reference of a parent class. So we will pass a reference and not just the object. Okay. So we will use the second type of definition in which we only pass the reference of the car. And then we can try to park the second car as well using the other type of definition. Let's say we try to park it on 0, 0. Okay. Now one important thing I noticed was, let's say when it tried to find a vacant spot. Let's say if there was no vacant spot, what should have happened? We should have actually returned something invalid. Okay. And we could probably print something as well to just let the user know that no valid parking space found. Okay, such error messages are good for the user, and you should also add some logging statements for the author of the code, like which is you right now, which will help you debug in the future that what actually happened. So if you notice, where are we calling find vacant spot? We are calling it in park. Now if spot.first equal to -1 or spot.second, okay, we can just check if it is greater than 0. That should be good enough for us. If spot.first greater than 0 and spot.second greater than 0 and spot.first less than rows and spot.second less than spots per row. So this means this is a valid spot and we can go ahead with parking. Else we will just we can just print that parking was not found. Sorry, no parking available. Okay. So now let's first try to run this code. We will first try to park C1. So what the parking lot will do is it will automatically try to find the first empty space and park it over there. Now when we run, when the line number 110 is executed, it will try to park the vehicle, park the car C2 explicitly at 0, 0, and if it doesn't match, then it should print the error. Now what I will do is I will also add a debugging function which prints the parking, because it will be helpful for us in case the code doesn't run as expected. So we'll just print the entire parking lot over here. Now the compilation was successful. If the code is also successfully getting executed, then I would be dumbstruck. We need to print the grid values because that is what is simulating the parking grid. Now let us print this, let us print the parking at each stage after it is created and after each car is parked as well. Print parking. Okay. Let us print after the first car is parked as well, and let us print after the second car is parked as well. Okay, it compiled once again, and if I run it, let me just check it again. I'm nervous. So calculate parking fee uses the calculate parking duration in hours, and I think this should work as expected because I googled it. All right. Now if you notice, first of all, it's a 3x2 parking, and in the first time itself it says sorry, no parking available. So maybe I made a mistake, and this actually satisfies me, because if the code ran as expected, it would have been quite terrific. Now if we look at what is actually happening in p.park &c1, let's try to debug it from there, what is happening inside the park function. So now this should actually be returning 0, 0. Okay, my condition was wrong over here. I should have used greater than equal to 0, because 0, like our vectors are 0 based indexing. I kept on saying that in the module, and I myself have forgotten about it. So now if you notice, something happened which should not have happened. Like when we created the parking, it shows an empty parking. When we parked the car for the first time, 0, 0 was the first empty space where the address of the car is present. But when we try to park it, when we try to park the second car, it is trying to overwrite the first car. Okay, which should not happen. If the car is already there in place, it should return that this is not a valid parking, there is something already existing. So now we should add something in the park code over here, which is trying to update it whatsoever. Now if grid of row num and spot num is not equal to null, we should not be parking, right? But we should not be returning no parking available, because parking might be available, it's just not available at this particular spot. Sorry, no parking available at, and let's find out the grid number as well, at row number, comma, spot number, spot. Now I think this should be good to go, and we can return it from here itself. Now how would we know whether this parking was successful or not? So possibly we might want to return a boolean over here which says whether the parking is successful or not. So we can return false in this place, because this was not a successful parking, and we can return true over here because this shows it was a successful parking. And we can also print this statement, like your car is parked at this row number and this spot number. Thanks for parking. Your vehicle is at Okay, I think this is good to go. If you notice, we are returning boolean here. So let us just propagate that part and we will return park here as well. Sorry, no parking available. So we don't require the else statement, because if the if condition is successful, we are anyways returning whatever the boolean was. And no parking available, we can just return false from here. Now this code has become really clumsy and we need to like properly bifurcate what functionality the first parking function should have and what functionality the second parking function should have. Okay, but at this moment I'm not too worried about it, and park is getting called only from the main function. So anyways we are printing something, so we don't need to worry about it. Let's try to compile and run the code again. If you notice, for the first time it says thanks for parking, your vehicle is at 0,0 spot and it has some address associated with the first vehicle. And when the second time it tries the second car to be parked at the same space, it says sorry, no parking available at 0,0 spot, and it doesn't change the address. The address of the first car remains as it is. So now what we can do is we can try to park it at some other spot. We can let the parking system decide where the parking should actually happen. Okay, now it should actually be parking at 0,1 grid number, but let's see what actually happens. So if you notice, first time it said sorry, the same thing happened, and then we tried to park it again using the default functionality. It said thanks for parking, your vehicle is at 0,1 spot. So this is what we expected. And if you notice, the parking of the the address of the first car doesn't change throughout, so that persistence is there. Now our code is actually complete and it is almost 30 minutes. Okay, so I will just add a buffer of 3 to 4 minutes to it, and I have completed the code along with the explanation and testing in 35ish minutes, which is a pretty good thing to do after having not written C++ code for a few months. Now how to test this we have already covered. I have talked about it. Okay, now let's just do one small thing before we wrap this thing up. What's next? Let's try to inherit another class. Let's try to inherit the vehicle class to bike class. Okay, so this should not be a tricky thing to do. We can just copy paste the car class and change it by bike. And in get type we can return bike instead, and here the parking fee can actually be 2 times the duration. Now one important thing that I probably missed out was not calling the calculate parking fee function. We have not called it at all. So when we are actually vacating, where are we vacating? We are vacating over here. So we are using v vacate spot. So instead we can, first we actually had to, before vacating the spot, we actually had to calculate the parking fee, or pay the parking fee. So that part was missing. We can implement both of them together. So vehicle pointer calculate parking fee, and what does it return? It returns me an integer. Okay, so int fee. Now obviously we have not implemented any payment mechanism, so it would be stupid to expect some payment to actually happen. Fee is whatever rupees are. Fee is rupees, and then a new line. Okay, now another thing which we have not implemented is actually leaving the car. So let's do all of that together. I hope it doesn't cause any issue. Let's have just one bike. Okay, and let's try to park the bike at a proper place. Park and B1, and we know for sure that 1,1 in this case is empty, because at the end, if you notice, only 0,0 and 0,1 places were occupied. So we can have 2,1 as well. Okay, and let's print the parking after that. Now we will also execute the leave part. let's vacate C2 first and then we'll print parking as well. And then let's vacate C1 first and then B1. Now hopefully this doesn't crash. It compiled successfully, and if you notice it is throwing me some jargon. That is all right. Why is fee some random thing? Calculate parking fee. What is calculate parking fee? Calculate parking duration in hours. And that should have been returning me 0 because like actually there are no hours in this. So let me just print a debugging statement here. Debug time duration dot count. All right. But now let's explore the other execution. Like let's check the other execution of the code. Thanks for parking. C1 is parked properly. C2 was not able to park. C2 is parked properly at 0,1. B1, the bike is parked at 2,1, which we wanted. And if you notice in the grid, there is another address for the bike. Now what we are doing for the first time, we are trying to vacate C2 and hence this becomes empty over here. And okay, now I realize what is the issue. The issue was when we were parking, we have not set our assigned time. Okay, parking start time is not assigned at all, which should have been assigned when we occupy the spot. Now I can just copy from here because we want to assign it to the current time, which is at the parking. Now probably I can just get rid of the debug statement as well because I feel I'm confident that this was the issue. Now if you notice, this is getting a bit cluttered, so let's add one more empty space so that it's easier to read. Now we can add another empty line after the parking is printed. Let's compile it once again and let's run it. So initially it's empty. First car is parked at 0,0. Second car was not able to park. Second car gets parked at 0,1. Bike gets parked at 2,1. If you notice, the addresses of C1 and C2 persist. Now while vacating C2, the fee is 0 because hours are 0. Because it was getting executed in real time, like it would be a fraction of a second. So the hours is going to be 0. And C2 is now empty, but C1 and B1 have their addresses persisted. Now we are vacating C1 or B1, I'm not sure. C1 we are vacating first and the fee for that is also 0, and at last we are vacating B1. So this is how the code should have got executed, and that's it for this particular project. But what I want you to implement is the last part. I'm not going to implement it. This is a take-home assignment. We want you to add designated spots for different types of vehicles. Okay, I have already provided you with the functionality of get type. You can use that to check whether this is a valid space for a car or for a bike or not. And you can also add an extra vehicle, which can be cycle in this case. Okay, I'm just giving random vehicle names. So you can just like have the cycle parked. You can inherit it from the vehicle class. And what you can actually do is you can take it from the input, like you can take it from the user, that in the grid what spots are designated for a car, what spots are designated for a bike, and what spots are designated for the cycle, and so on. And you can implement it and upload it to GitHub and share the GitHub link in the comment section below. And just let me know how it goes. I am sure you would learn a lot of things while you are implementing this part. Thank you. So I really hope you enjoyed this content and found it insightful. If yes, do give it a thumbs up. Put down your opinions in the comment. If you have any doubts, you can put them down in the comments as well. Lastly, don't forget to subscribe to Scalar's YouTube channel and hit the bell icon so that you never miss out on notifications.